Alrighty, Algebra 1. Today we are starting kind of a new section. We're going to leave quadratics at rest for now, and we're going to start looking at this idea of inequalities, which I know you've been exposed to before, but we're going to kind of refresh our knowledge, and then in the next sections kind of move on to more Algebra 1 level inequalities. So I would recommend maybe today you might want to get out a highlighter. You can certainly use pencil, but we are going to be doing some shading on number lines, and so that might work out well for you. Okay, so the first thing that we are being asked to think about is how can we represent solutions to the given inequality on a number line? In other words, what value of x will make each inequality true? Okay, so if we look at A, the first inequality is saying x is greater than or equal to -2. Now we might want to stop at this point and remind ourselves that when the big mouth is opening to the left, this means greater than or equal to. Okay, and then when the small mouth opens to the left, we read that as less than or equal to. Okay, so the or equal to is when there is a line below the gator mouth. Okay, so going back to part A, it says, what values of x are greater than -2? So let's think about that on the number line. All you have to ask yourself is, what numbers are greater than -2? Well, -1, 0, 1, 2, 3, and so on. Okay, now I just got done saying that the line underneath the gator mouth means or equal to, so we have to also include -2 in this scenario. Okay, now I always ask students, is it just the whole numbers? Are there any other numbers that we are missing? Okay, so if we think about, for instance, maybe I'll draw an arrow right here. This is 4.5. Is 4.5 greater than -2? It sure is. So how are we going to graph this inequality right here? Well, because there's no y's, we're going to use a number line. We're not going to use an xy coordinate plane. And we are going to start at our given point of -2. Oh goodness, this is going to be hard for me to fill in. Okay, and then from here, we are going to go ahead and shade in this direction of the number line. So I'm showing you with my pen how you would do it with pencil, but with a highlighter, we can just certainly make sure that that boundary point is set and then highlight everything toward the greater end, and we always want to bold that arrow. So that is our first number line problem. Okay, now the next problem on B says x is less than or equal to 1. Okay, so first of all, I just said or equal to 1. So right away, I am going to put a solid dot at 1. Solid dot. Okay, and then we're thinking about what numbers are less than 1. What values of x would make it true? If I think about putting -6 in for x, is this true? Is -6 less than or equal to 1? It sure is. Okay, so that's how we kind of can check and think about our work. So we could think -3 is less than 1, 0 is less than 1, and so on and so forth. Sorry, the train's coming through and I have my windows open. It's a nice day out. Okay, so we are going to shade in this backwards direction in this case. Okay, and some of you guys may recall from middle school that when our variable is the first thing in the inequality, meaning when it's on the left-hand side, okay, look at the inequality symbol. It says less than. Less than can be looked at as like an arrow that is pointing in this direction. Okay, look at the inequality sign on the first one. It said greater than. It's kind of like an arrow pointing in that greater than direction. But be cautious. You can only use that trick when your x is on the left-hand side of the inequality. Okay, now on part C says, what values of x would make this statement true? X equals 3. Well, what's the only number that equals 3? 3. Okay, so the solution on this problem would just be a point at 3. Are we going to shade in anything? No, because when there's no inequality sign, you're not going to shade. All right, so in this case, we see this is asking what numbers are greater than or equal to 0. You can always pause me, by the way, if you can do these problems, or try them and then play me through to see if you're on the right track. Okay, so we have what numbers are greater than 0? Well, I know that 1 is greater than 0, 4 is greater than 0, 10 is greater than 0, 1 million is greater than 0. Okay, but we also see the or equal to sign, so we need to put a closed point on 0, okay, and I'm emphasizing that, and you'll see why here in a little bit, okay, but we're going to put a closed point on 0, and then we're going to go ahead and shade in the positive direction because it's all values greater than or equal to 0. Now we're back to E, where it just talks about what value of x is equal to -2. Well, how many options do we have? We have one option, and that is at -2. When there's no inequality sign, we are not going to shade. Okay? Now we are looking at a two-part inequality. Okay, so how are we going to read this? This seems a lot like, I'm going to write it out because you guys have gotten really good at it. This seems a lot like domain. Okay, this is saying what values are between -1 and 4. Okay, what is this really saying? It's saying x has to be greater than or equal to -1 because look, the big mouth is pointing toward the x in the first inequality, but then it says also x has to be less than or equal to 4. Okay, so we are thinking when we see a two-part inequality, we are thinking between. So, what numbers are greater than or equal to -1? Well, we can first start by putting a point at -1 because the or equal to sign says that we have to do that. And then we also see that we need to put a point at 4 because we can be equal to 4. So what's greater than 1? Or -1, but less than 4, it's everything in between those two dots. So you are going to take your pencil or your highlighter and shade between the dots. Okay. Now this is an interesting one because we have x squared is greater than 4. So we have to square values that we input. So if we think about what value squared is going to get us equal to 4, okay, well we know that 2 squared equals 4, so we've got to represent that right away, okay? 2 squared is equivalent. Now from there, what's going to get us greater? Okay, well you have two options. Either we can check 1 or 3, but when I do 1 squared, it's 1. Is 1 greater than 4? Absolutely not. But if I take 3 squared is 9. 9 is greater than 4, so what am I going to do? I'm going to see that all these values squared are going to be greater than 4. But we have to pause and kind of think about quadratics for a second, and we have to think about negatives as well. If I take -2 quantity squared, what is that? That gets me 4 as well. So I also have to consider -2. Now what happens when I take -3 squared? That's 9. Is 9 greater than 4? It sure is. So this is another two-part inequality, okay, but we don't have between. We have two separate sections going in opposite directions, okay? And on the final one, we finally come across something that has a less than symbol, but it doesn't say or equal to, okay? So let's think of values that are less than -3. Okay, we know that, I'm going to put little tick marks, -4 is less than -3, so is -5, -6, and we can see that the arrow is telling us to shade in this direction. Okay, but what else is less than -3? I think that -3.5 is less than -3. I think that -3.1 is less than -3. So how are we going to represent getting super duper duper close to -3 but not including it? You may remember this from middle school. We are going to put an open circle. So you have to be careful if you're going to use a highlighter because you have to make sure that you've established that the boundary point, okay, is on -3, but we cannot include -3. So this is a representative problem of an open circle. We use open circle when it is not equal to. So if there's no under or line underneath the inequality sign, you have to use that open circle. That's an important note. Okay, so now we're going to look at the number lines that we just completed and answer a few problems. So based on what we just did, let's look at solutions to inequalities, like x is greater than or equal to -2, versus equations. Okay, so key words came from that question. Inequality has an alligator mouth. Equation has just an equal sign. Okay, so what is the difference? Well, hopefully you see that right away. I'm going to actually use my typing tool, I think. Okay, we can notice that inequalities have more than one solution. Okay, so because we have more than one solution, we must shade to represent all of the solutions that make the statement true. There's kind of no way around it. We would be sitting there forever putting points on values of x that would make it true. Okay, but then if we think about an equation, if we think about an equation, we see that equations usually have a limited number of solutions. So because of that, we must use specific points to represent those solutions. Okay, sorry, that got kind of into my other question. So the kind of moral of the story here is that inequalities, we have to use shading. On equations, to represent a solution on a number line, we just simply use points. Very important. So along those same lines, on question B, it says how many solutions does an inequality like x is less than or equal to 1 have? Now if I redraw the number line very quick to represent the solutions to this, okay, usually I put 0. My boundary point is going to be at 1, right? And it's or equal to, so it's a filled in circle, and it's everything that is less than. Sorry, my TV just turned on and it just scared the living daylights out of me. Okay, anyways, back to focusing on algebra. Whew. Okay, how many solutions does this inequality have? Well, we have everything less than 1. So where are the solutions going to occur? This is a solution. This, and I could just keep drawing little tick marks to represent all of the numbers on the number line that would work. So how do we represent something that we can't even count up? We see that most inequalities have infinitely many solutions. Because we have to remember all of the decimals and fractions that are between the whole numbers that we so often like to focus on. Infinitely many solutions. When you shade, you are shading over thousands and millions of points. Okay, now, the final thing that we want to consider is how is the result of these two inequalities. We had the x is between -1 and 4, where we have the gator mouth in both instances being less than, but we know that it means between, okay, versus the result of when we had x squared is greater than or equal to 4. Okay, well, if you recall, this first one had 2 points, and we looked at everything in the middle, right? And then the second one had 2 points, and what did we look at? Everything in the opposite directions. So we see that this first inequality is a 2-part inequality that forms what I'm going to call an interval. Okay, and then in the second point, an interval with 2 endpoints. And then in the second inequality, we still had 2 points, but we're going to call those starting points that continue in opposite directions. Okay, so two regions continuing in opposite directions. And we're going to look at that more over the next few lessons. Okay, so now what I'd like you to do is pause the video and try this next problem on your own and then check your answers with me. We are being asked to write the inequality that represents the solution they've given us on the number line. So we're reversing the process, okay? So go ahead and pause me, try them out, and then check your answers. Okay, in this problem, letter A, I see that 1 is being compared to x, and I always want to start with my x first. Okay, so then I'm thinking, what are all these numbers compared to 1? Well, x is everything larger than or equal to, because of the shaded circle, 1. Okay, now we can always check ourselves. This arrow is going in the same direction as this arrow, but you have to make sure that you placed your x first. So this is the answer or the inequality we're looking for. Okay, on the next one, we can look at x being compared to 1 again, but what are all these numbers compared to 1? X represents everything that is less than but not equal to, because of that open circle. Okay, now again, I see that this direction of the arrow looks like the arrow that I just drew here in my inequality, or the gator mouth, I might say. On the next one, I am comparing x with 3, and right away I see a closed circle, so I'm going to have or equal to, and all of these numbers are less than 3. Okay, and you can always check by plugging in a value. Let's look at like -4, see if it makes sense. Is -4, if we replace x with that, less than or equal to 3? Yes, it is. So always just plug in a value in the shaded region to make sure your statement truly makes sense. And then finally, we have a interval. Okay, now when have we worked with intervals? Again, I'm reminding you of domain, something you can relate to. So right away, when you see your interval, you can set up the same template like you did for domain. Okay, remember, we're going to put a number here, we're going to put a number here, and then we're going to think about first our boundary points. We have an open circle, so we're going to leave the first gator mouth without or equal to, but then the second gator mouth has to have the or equal to because it's shaded. Now we're thinking about our lowest value, so -4, and then our highest value is 2. So what does this mean? X is everything that is greater than -4 but less than 2. In other words, x is between -4 and 2. So there is that template again. It's coming back to haunt you if you didn't learn it for domain, but here's your opportunity to go ahead and learn it. Okay, I'm going to go ahead and erase these lines so that you don't get those confused with or equal to. Okay, now we are going to consider kind of diving a little further into more of like Algebra 1 type inequalities. So let's look at this more complex inequality, which is kind of related to mx plus b, linear family of functions, right? I see that this says 2x minus 5 is greater than or equal to 3. Now I want you to pause me for a second and just kind of use a guess and check approach and figure out 5 numbers that if you plug it in for x, that those would make the inequality true. Okay, so I am thinking, okay, what if I plug in 3? 2 times 3 is 6, 6 minus 5 is 1, but 1 is not greater than 3, so that's not going to work. Okay, so I'm going to try something higher, maybe a 6. Let's check. 2 times 6 minus 5 is greater than or equal to 3, so 12 minus 5 is 7 greater than 3. Yes, it is, so 6 is a solution. Okay, now we could say 7 is probably going to work because I'd have 14 minus 5. 8's going to work because then I'd have 16 minus 5, and that number would just keep getting bigger and bigger. Okay, but my question is anything lower than 6 work? Okay, well, if I have 2 times 5 minus 5, is that greater than or equal to 3? Well, 10 minus 5 is 10 minus 5 is 5. Sorry, I am just having all sorts of brain freezes today. Is greater than or equal to 3. You're probably screaming at me through your computer. Okay, so 5 would work. Now can we get even closer? Is 4 going to work? So we have 2 times 4 minus 5 is greater than or equal to 3. Well, we have 8 minus 5 is 3 greater than or equal to 3. That or equal to saves us. Yes, it is. But are we going to be able to go any lower than 4? I don't think so, because anything lower is going to flip that inequality. Now I'm going to cheat and see that because 4 is the lowest we can go, I'm just going to say, well, 4.5 has to work as well, just to remind you that decimals can work. So how many solutions are there? What if I kept going? Hopefully you're saying this out loud right now. Infinitely many solutions. Okay, whenever we have an inequality, that is your cue. Almost always, it's going to be infinitely many solutions or no solution. Okay, so what is the smallest solution for x? We said x equaled 4 was the smallest solution. Okay, that is what we are going to call the boundary point. Now, what is so special about the boundary point? Okay, well, the boundary point will always makes both sides equal. It will always do that. So whenever you're asked about a boundary point, this is important vocab, so get it written down. Boundary points make both sides equal. So we want to take advantage of that because we have been working with equality this entire year when we solve equations. Okay, so I'm going to show you kind of how, instead of using this guess and check up here, how we could have done this systematically instead of trying to figure out what value is going to get us to our boundary point. Okay, so what can we do? Well, we can treat our inequality like an equation. And when we treat like an equation, that is going to give us the value of x that makes both sides equal, so that is going to find our boundary point. So if we go ahead and go through this problem, if I treat it like an equation, okay, put my equal sign in, not 0, it should be a 3. Then we just simply solve. You guys know how to solve this. We're going to add 5 to both sides, so we get 2x equals 8. We're going to divide by 2 to both sides, so we get x equals 4. Okay, that right there is a very special point because it is indeed the boundary point. Now at that point then we have to figure out, okay, is it all numbers to the right or is it all numbers to the left, okay, that we need to shade in? So that's the question that you would be asking yourself from there. So we want to write an inequality that represents the solutions for x, and then we're going to make a number line and highlight the solutions. Okay, so oftentimes when you're given the inequality that you see right here highlighted in blue, you're going to be asked two things. You're going to be asked to write an inequality, and then you're going to be asked to highlight the solutions on a number line. Okay, so we already know if I work on the number line first, put my 0 in, my 4 is the most important, and usually I just kind of mirror image that. Okay, so 4 is the boundary point, and if we look at the original inequality of 2x minus 5 is greater than or equal to 3, the greater than or equal tells me that I'm going to shade in the boundary point because it's or equal. Okay, now we have to use test points. Okay, we want to test numbers that are on opposite sides of the boundary point. So we're going to test 5, and I want to test 0 because 0 is really easy. And if one of the two works, that's where we shade. Okay, so when we test, I'm going to say, well, 2 times 0 minus 5, is that greater than or equal to 3? Well, 2 times 0 is 0. Is negative 5 greater than or equal to 3? The answer is no. So do I want to have 0 be in the shaded region? Absolutely not. Okay, but then at the same time, then we can test something. We never test the boundary point. Okay, 2 times 5 minus 5, is that greater than or equal to 3? Well, we've already done the problem. 10 minus 5. 5 is greater than or equal to 3. Yes. So when you get a yes, that means that is where you shade. Okay, now some of you guys are going to want to say, okay, well, we already knew that because the inequality sign right here was pointing in this direction. Well, and X was on the left side. Okay, well, it's not that clear cut when you have coefficients and a mess, I'll call it, around the X. Okay, you can use the rule when it's just X next to an inequality symbol, but when we get complex like this, you can't jump to conclusions. You have to either use a test point or use the strategy that I'm going to show you on this last problem of the notes page. Okay, so it says we want to go ahead and solve the inequality. 3 minus 2x is less than 1. Okay, now you may have seen some of this in middle school, but the first thing that we want to do is we want to find the boundary point, BP. Okay, now how are we going to find the boundary point? By treating it like an equation and solving. That is the first step. Okay, now we have 3 minus 2x equals 1. So I'm going to subtract my 3. I have negative 2x equals negative 2. Divide by negative 2. So I get x equals 1. That is my boundary point. So from here on my number line, I have 1 and negative 1, and then I just need to figure out, it's going to be shaded because we have, or sorry, is it going to be shaded? Yikes. No, it's not, because it's not or equal to. So I'm going to put my open circle at 1, and then I'm going to test. All I ever have to do is test 2 points. I'm going to test 2, and I'm going to test 0. Okay, so if I test 0, I'm asking myself, I always put a question mark there, is 3 minus 2 times 0, is that less than 1? Well, you have to do the math. 2 times 0 is 0. Is 3 less than 1? Absolutely not. Don't just be a robot and say yes or no. You have to check. So then, now we're going to do 3 minus 2 times 2. Is that less than 1? Well, 2 times 2 is 4. 3 minus 4 is negative 1. Is negative 1 less than 1? The answer is yes, it is. So when we say yes, that gives you the region that you need to shade. So we need to have 2 be included in the shaded region. So what is the solution written out in inequality form? We always start with x. So maybe I should write that as the solution. The solution is x is everything that is greater than 1. Okay, now remember that arrow can go in the direction of the shading. So that's what you'd need to give me along with the number line. Okay, now some of you guys are not going to want to always use test points, so I do want to expose you to how you eventually will want to do these. So let's say we're going back to the original problem, and the original problem was 3 minus 2x is less than 1. Okay, you can treat this like an equation, but keep the inequality sign there. Okay, so treat like an equation, but keep that inequality sign as is. So the first thing we're going to do is subtract 3 from both sides, and we are going to get negative 2x is less than negative 2. Now from here, we're going to divide both sides by negative 2, but think about if we do that, we are going to get the answer of x is less than 1. But what was our answer above? It's x is greater than 1. So this is the key as to why I'm hesitant to ever show this. Okay, if you are dividing or multiplying both sides of an inequality by a negative number, this only occurs when you're doing it by a negative number, you must flip the symbol. If you don't, you will get the opposite answer and it will be marked wrong. Okay, so from here, we have to go ahead, or actually I can just go ahead and continue my work. Okay, I can see that the negative 2's cancel out. I have to flip my mouth, and there is my answer. Again, this only happens when you're dividing or multiplying, so this has nothing to do with addition, when you're dividing or multiplying by a negative value. Okay, so then at this point we got the inequality first, so then we could go on a number line and we could graph it pretty easily by saying, okay, put my open circle at 1, and it's going to be all numbers that are greater than, I can follow the direction of that mouth. Okay, so that is our first lesson on inequalities. We're going to continue to dive into this idea. Please make sure you're keeping up and letting me know if you have questions. I always check my email, and we can set up either a Zoom chat or I can respond back. Keep working hard. I really appreciate seeing all your hard work. It's not going unnoticed, and we will talk to you next lesson.